Welcome back to Light O'Clock. Today on the podcast, we're tackling vaccines. Specifically, in today's episode, chronobiology meets vaccines. We are asking, is there a best time for a vaccine? Does receiving a vaccine in the morning or in the afternoon lead to different immune responses and potentially better protection? To shed some light on this topic, I spoke with Cathy Wyse.
I'm Cathy Wyse. I'm a research fellow at the University of Edinburgh at the moment, and I'm a chronobiologist, and I'm interested in lots of different areas that the circadian and seasonal timing systems affect human health and disease.
Cathy and her colleagues published a systematic review titled Circadian Variation in the Response to Vaccination, a systematic review and evidence appraisal in March 2024. Which is why I contacted her to be a guest on this episode. Preparing this episode with Cathy was really fun because she's a keen Light O'Clock listener. And so she knew exactly what kind of questions we had to get into to make a good episode. She also made me blush right at the start.
You're doing an amazing job, and I can't believe you're a PhD student. It's a great service to chronobiology, so I'm very happy to be here. Thank you for the invitation.
Thanks for making me blush. I'm happy we're not doing video, actually. But Cathy is also a great speaker and a very curious scientist, which always makes for an interesting conversation. She actually got into the topic of vaccination, like many of us, during the pandemic.
I was always interested in the immune system because it's a very good way of kind of measuring the human circadian clock. The little immune cells have their own rhythms that we can measure. But my interest in vaccination, and especially in the time of day of vaccination, started during the pandemic. I think a lot of scientists were working from home and thinking like, what can I do to contribute to this? And, there was molecular biology labs making hand sanitation solutions, and everyone wanted to contribute. And I think that's what kind of got me really interested in this. And also because at that time there was a lot of kind of misinformation about the timing of vaccination. So, a lot of people were saying you should get your COVID vaccine in the morning. And I was a bit concerned about that, and I wanted to explore how much evidence there was to support that. So I guess those things together, that was kind of my COVID project to work on this systematic review.
And so with Cathy, throughout this episode, we will first get everyone on the same page about how circadian rhythms influence the immune system, how vaccination works, and then we will dive into the work Cathy did to answer the question, is there a best time for a vaccine? Could you briefly explain how circadian rhythms influence the immune system? So are immune cells more active at certain times of day, or is it a little bit more complicated than that?
Oh, yeah. I think the immune system is always a little bit more complicated, isn't it? So, I think the main thing about the immune system and circadian rhythms is to remember that all of the immune cells have their own circadian clock. And it's the same sort of machinery in all of the other clocks as well. And that gives their function a circadian rhythm as well. So it's not so much that they're active at different times. It's more that their entire function has a circadian rhythm. So their migration, their activation, their metabolism all shows circadian rhythm. And it's kind of different for every immune cell as well. And they all work together. So the whole system is very, very complex. And I think we don't really understand how those mechanisms all work together. And there's amazing research groups all over the world working on the molecular function of the circadian clock in the immune cells. So it's something that we'll understand better in the future, I hope. But in terms of what those kind of circadian rhythms look like, so a really good example is cell trafficking. So that's when the white blood cells move between the blood and the lymph nodes and the bone marrow into the tissue. Those kind of movements are very circadian. So, like, for example, the lymphocyte cells increase at night in the blood. And the other types of cells, like the macrophages and the neutrophils, those kind of inflammatory cells, they tend to increase in the day. But it's actually really complicated because the rhythms and the function are not they're not really linked together. So I think to summarize all of it is that it's a very complex system. We know that the human immune system is circadian just because we see circadian patterns in the cells in blood. But in terms of the function of those cells and their circadian rhythms in the human immune system, that's something that we don't know a lot about. And a lot of the information is fed forward from animal studies.
I see. So we still don't know kind of what that means in practice.
Exactly. Like we know the cells are, the concentration or the numbers of cells in blood at different times of day is different in humans. But the sort of implications of that are much harder to understand, the kind of functional rhythms in humans. But like I said, there's really amazing research groups working on these kind of problems. So I'm very hopeful that in the future they'll have uncovered more about that.
Now, coming to the topic of vaccines, I think the audience might be familiar already with how vaccines work, but I think it's always good to give a little bit of a recap. So how do vaccines work? And what do researchers mean when they talk about a vaccine response?
Yeah, so I think we all learned a lot about vaccination in the last few years. But the purpose of the vaccine is to sort of prime the immune system to recognize the pathogen before the real infection is encountered. And that allows us to be exposed to the pathogen at a later date. And your immune system is able to remember how to respond to that specific pathogen. And so it's essentially exposing you to a part of the pathogen that doesn't cause infection. So it's allowing that immune response to be triggered without the disease. So it's quite amazing, actually, isn't it? Sorry, your second question then was how do you measure that? And that's an amazing question. Like it's so hard to do that in humans. So the way that it's normally done is to measure the antibody response. So the antibodies are these little structures that are released from the immune cells that target the pathogen. And after vaccination, you can detect an increased level of those antibodies in blood compared to before the vaccination. So usually the most common marker of vaccine response is that increase. The vaccine effectiveness is a different sort of parameter. So that's measuring how much protection that vaccination is giving you. So they're kind of related because if you've got a good antibody response to the vaccine, then that's related to having for the vaccine giving you good future protection, but they're not the same thing. So it's a very easy thing to measure the antibody response, which shows you've been vaccinated, you've responded to it, but it's not equivalent to knowing how effective that vaccine was. To do that, it's really difficult. You've got to follow people that have been vaccinated and see how many of them actually went on to be infected with the disease when they're exposed to it. So there's a very easy, simple way that's not really the most effective. And then the sort of standard way of looking at infection rates post-vaccination is actually quite difficult to do.
So this is an important distinction to keep in mind for the rest of the episode. When researchers talk about vaccine response, they often mean immune markers such as the level of antibodies. Whereas vaccine effectiveness, as Cathy said, refers to how well the vaccine actually protects people from catching the disease later on. And, before we get really specifically into this topic, I have a broader question, which might make you smile a little bit. But when we're talking about whether vaccination response or vaccination effectiveness is influenced by time of day, why are we interested in understanding this? Like, why does it matter?
Oh, it matters for so many reasons. Like, I think the reason that straight away springs to mind is that it could improve the clinical effectiveness of vaccination. So if we knew that vaccination at a certain time of day was more effective, so it gave more protection against disease, then that would be a very easy way to improve outcomes, It would be amazing. We would just, in the clinical setting, target the vaccination of people at those times of day. So that would be the number one. But I think number two reason is that it tells us a lot about the immune system as well. So it's very interesting that there are different times of day that the immune system seems to be more effective. That's very interesting. So if we knew that, we could look at why is that? And is there any way of translating that improved immunity to maybe another drug or another treatment, or being able to monitor how susceptible to infection people are? Or I think it's a very interesting kind of biological observation, as well as having potential clinical implications. So,
yeah, let's talk about this systematic review that you conducted on vaccination responses and time of day. So systematic review basically means that you summarize the existing evidence in a very organized way. And so let's review a little bit the studies that you found. What kind of studies were they? Which vaccines were included in these studies?
So, yeah, it was a systematic review. And actually, things are moving so quickly that it's actually a little bit out of date now. I think I need to write another one. There's been a lot of really amazing studies in this area since then. So when I wrote this, there was sort of three different types of study. So the first one would be just observational studies. So where they just, people were being vaccinated anyway. So they just looked at the time of day and then they related that to antibody responses. So that's observation. They didn't change anything. And then the second one would be sort of experimental medicine studies where they actually planned the vaccination. So the people were being vaccinated anyway, but they sort of fed that into a study design. And then there's randomized control studies. So those are the ones where it's absolutely people are allocated to different times of day in a random fashion. And then there's population studies. So that's where they look at, say, for example, during the pandemic, when there was COVID vaccinations, they can look at the population. So of all the people that were vaccinated, well, not all, but a percentage of the population that were vaccinated, did the time of day predict whether they went on to be infected or not? So lots of different study designs, which adds to the kind of difficulty of coming to a final answer as well,
So to give you a little bit more detail, in her review, Cathy selected 23 studies published between 1967 and 2023. 11 of these studies investigated the effect of time of day on vaccination against SARS-CoV-2, so the coronavirus. And 7 looked at influenza vaccination. And then the other studies looked at different types of vaccinations. Most of the studies measured vaccine response, so for example, antibody levels, and only a few measured vaccine effectiveness, meaning the likelihood of later infection. So as we were saying before, measuring vaccine effectiveness is a little bit harder, and that's why not many studies do this. An interesting thing that we discussed with Cathy is what times of day were actually compared in these studies. There's also a time where people just cannot get vaccinated because there's just no staff to vaccinate people, right? So I don't remember exactly how it was during the pandemic, but at 11 p.m., you're not very likely to get vaccinated.
No, I actually don't think there was any study that was vaccinating at 11 p.m. I think the latest usually is around 8 o'clock. And in fairness, like most studies, the hours that they're comparing are sort of 10 till 12 and 2 till 4. So it's quite a small chunk of the active period, so it's not like we're ever comparing day and night. We're comparing like 2 or 3 hours apart appointments. So it's quite narrow.
Another big limitation of these studies was how morning and afternoon were defined. The timing was quite inconsistent. In some studies, morning could mean anything up to 2 p.m., while in others, afternoon already started at noon. So even before looking at the results, we have to remember that different studies were not always comparing the same things. And so considering all of this and also all, the limitations that we already mentioned with, for example, we're not actually looking at the 24 hours, but just specific times of the day. What is the picture that we get here? So what does the evidence suggest overall? Is there a best time for a vaccine, or do we get a mixed picture?
Is morning better than afternoon vaccination? The sort of things that I took from the systematic review, so there's a lot of variation in all of the studies. It wasn't possible for me to sort of merge any of the data together to do a meta-analysis. And there was some studies that reported that vaccination in the evening times afternoon, evening times would have a better response. And then others that didn't find any response at all. And then others that showed a response, that the response in the morning was better. But there was no consistency. I really wasn't able to make any kind of conclusion. So, yeah. And actually, since then, the studies that have been reported since then, that are a lot better. And there have been a lot better systematic reviews as well. And actually, this kind of finding hasn't changed, that really there's a lot of variation, a lot of inconsistency across this research question. So I think we're not really in a position to say that any vaccine is more effective at different times of day. But it doesn't take away from the finding that the immune system is different at different times of day. I think that's really important. And all of the variability, a lot of that will stem from us not knowing enough about the human immune clock. So it's different between people, and we're saying, okay, it's morning time. But actually, that isn't true for everyone, So for some people that have a very late chronotype, for example, their morning is going to be a bit later, and they might be tipping up into the afternoon category of the research study, So I think a lot of the variability will come from us not being able to characterize the human clock very well.
What Cathy is mentioning here relates to the concept of chronotype, which we have often talked about on the podcast. Basically, the question of morning versus afternoon vaccination becomes even more complicated when we take individual chronotypes into account. For example, a late chronotype going to a morning vaccination appointment might be in a very different biological state compared to an early chronotype going to the same appointment. The clock time is the same, let's say 10 a.m., but their internal body clock phase is probably very different. And so this could add noise to the data.
That's a big problem for this research question, that we can't actually measure circadian phase very well. So you can't measure the peak of someone's clock. And again, I think that's coming, that there's amazing researchers working on that as well. So at some point soon, I think we'll be able to kind of characterize human circadian rhythms in a kind of more quantitative way, and then use that tool to look at the timing of lots of different types of medication. But I think one big source of variability, probably the biggest one here, is why were you going for your appointment in the morning? So if it wasn't random and you weren't told you have to go at that time of day, then it could be because you're a morning chronotype, and that means you're healthier. Could be that you live closer to the centre. That's, where the vaccination centre is. So that's another source of bias. It could be people at work go for their appointments earlier. There's a lot of reasons that might cause someone to choose that. So if that isn't randomized, then I think that's straight away a big source of variation. So they're extremely difficult studies to do, these kind of in the clinical settings. It's really hard. I'm really impressed with people that manage to do this at all. But definitely randomization of the appointment times. Otherwise, we know that sicker people tend to make afternoon appointments, and healthy people, just morning people, are healthier. So, of course, their vaccination response is likely to be better. Geography as well. If the centre is in maybe a poorer part of the city, then people that live closer might come earlier. And then people that live further away, that might be wealthier and healthier, then maybe they come for afternoon appointments. So there's lots of factors related to human lifestyle and demographics that could affect the time of day of vaccination. So I think that's an important source of variability. And yeah, it's something that we need to consider in these kind of study design.
And now that we're talking about variability, we talked about time of day, and now we're talking a little bit about lifestyle, demographics. Something that comes to my mind, which I also find interesting, is sleep. So, it might it also be that how much you've slept the night before, or how much maybe you sleep the night after you've received the vaccine, that influence your response?
Yeah, definitely. So that was outside of the scope of my review, but it's something that's very interesting as well. And I think in general, there's probably a bit more evidence for sleep being important. But once again, it's not straightforward. So a lot of studies looked at if you sleep badly, is your vaccine response lower? And it is usually. But that's really not surprising because people that are sicker are likely to have poor sleep. So it doesn't mean that if you sleep well the night before, that's going to make your vaccination work more efficiently, So it's just, it could be just confounded by the fact that somebody is a less healthy person is likely to have poor sleep. But there have been some studies that electively sleep deprive people before vaccination and also showed that this antibody response wasn't as good. But they catch up later. So if they follow them over a longer time period, then the difference disappeared. And in any case, it's quite small. So, and again, there's a good bit of, those studies about sleep are not terribly consistent either, but there is evidence that sleeping well is associated with having a good response to vaccination. It's actually associated with most good health outcomes, good sleep. So it's not really that surprising.
And so coming back to the question of time of day and vaccine responses, where do these findings leave us in terms of making public health recommendations? Well, at the moment, we are not really at the point where there is enough evidence to recommend a specific time of day to get vaccinated. Another important point is that even if future studies do find a time of day difference, that difference would have to be meaningful from a clinical perspective before public health policies could change.
And another thing is that it's possible there is a time of day effect, but to change vaccination procedures, it would have to be clinically significant. So it would have to actually give you an advantage to be vaccinated in the morning if you did go on to meet the pathogen later. And we don't have evidence for that at all, So it isn't even just that we need to show there is a difference over the day. We need to show that that difference makes a clinical impact, so it actually affects it. So it might be a very small difference, and that's very interesting to chronobiologists and to immunologists, extremely interesting. But actually, to the people that are vaccinating the public, the difference is so tiny that it isn't worth changing anything.
And do you think there are specific groups where vaccination timing might be especially relevant, for older adults, shift workers, or people who are already maybe challenged with weaker immune responses? You mentioned that what we need is really a good randomized control trial. And would there be like a population here that would particularly benefit from this?
Yeah, so of course, in terms of the effectiveness of vaccination, we're mostly interested in the people who already have a poor response. So that would be people with a compromised immune system. So maybe transplant patients, for example, or older people have a much smaller response to a vaccine as well. So those are two examples. And I think we're on to another complexity here because both of those groups also have a very dampened circadian clock. So there's two things there that, their clock is disrupted anyway. So whether that makes the time of day effect greater or smaller. I don't know. And I'd refer back to my earlier question that like we really need a better way of characterizing the human clock to be able to look at what's going on with these people. Like, for example, with shift workers, where is their clock? Like, which is their biological morning and afternoon? So I think showing a difference in those more vulnerable groups could be even more difficult, but has, that has a much bigger benefit overall than vaccinating healthy people that are going to respond very well all the time. So I think the people that would benefit most from the time of day of vaccination would certainly be those groups.
At the end of our conversation, I asked Cathy what her main take-home message was from this whole research journey.
Yeah, so I think my take-home message is that we don't have enough evidence to support any change in vaccination timing at the moment. I think like there's lots of things that I'd like to see sort of in the future. So like one thing is when pharmaceutical companies are doing these big, huge randomized controlled trials and not recording the time of administration of the medication, like that's a very simple change if they can do that. And then we're starting to be able to look at a population level and to look at those kind of vaccine effectiveness outcomes rather than just change in antibodies. So I think that would be a very easy thing that can happen in future. And it is happening actually. And so people are getting vaccine timing data from retrospective randomized clinical trials. So that's really good information. And also something that you just brought up a few minutes ago, like to look at sleep as well. So just to make sure that in studies of vaccines, that sleep and time are recorded, and that data, we can use that to sort of to ask these questions in a bit more depth.
And this is also where we have to be very careful as scientists and science communicators. Vaccination is a topic where communication really matters, and we should avoid making strong claims unless they are backed up by solid evidence from randomized clinical trials.
Very easy to say, oh, morning vaccination was more effective. But actually, some people in the morning were healthier, or the afternoon people traveled further, or there can be lots of reasons related to sort of human lifestyle and demography. And that doesn't translate from the animal work at all, So that's really important. And as well to think about like where vaccination has brought medicine. And, it's quite sort of concerning to think that like vaccination hesitancy is one of the top threats to human health identified by the World Health Organization. So this is a big, big topic, vaccination. So research has to be, all recommendations have to be evidence-based, and that evidence has to come from randomized controlled trials. And actually another interesting thing that I noticed, the World Health Organization also say that one of the causes of vaccine hesitancy is inconvenience. So people don't get vaccinated just because, oh no, I'm going to have to travel, or there's no bus route there or something. So it's that simple. And if we were to say, it's better to be vaccinated in the morning, so the clinics are going to be open between 10 and 12 or something, and then people will be like, oh no, I'm going to have to get time off work, or I've no one to mind the kids, or just these normal everyday things might mean that they don't get vaccinated. So then at a population level, vaccination in the morning would actually reduce the efficiency of vaccination. So it could end up causing the problem that we're trying to address. So I think there's a lot of, this time of day vaccination is very complex, and a lot of the issues are related to sort of human lifestyle and human demography, and that the studies in the lab just can't predict that at all.
So with that, let's summarize what we've learned today about vaccines and time of day. First, the immune system is rhythmic. Many immune processes change across the day. which makes it biologically plausible that the timing of vaccination could matter. Second, most studies looking at the effect of time of day on vaccination do not measure whether people later become infected. Instead, they often measure vaccine response, such as antibody levels. That's very useful, but it's not the same as proving better real-world protection. Third, the evidence so far is mixed. Some studies suggest that time of day may influence vaccine responses, suggesting, for example, that morning vaccines are better than afternoon vaccines or the other way around. But the studies differ a lot in design, vaccine type, population, so older or younger individuals, and also how they define morning and afternoon. Fourth, individual factors probably matter. Age, sex, chronotype, prior immunity, health status, and sleep may all influence vaccine responses. And they may also interact with time of day. And finally, from a public health perspective, we are not yet ready to recommend one specific time of day for vaccination. But that does not mean people should worry if they cannot get a morning appointment. The most important message remains that vaccines work and that getting vaccinated when you can is much more important than trying to find the perfect time. And with that, I hope you enjoyed the episode. I'll catch you next time at the end of August for an episode on cancer, circadian rhythms, and light therapy. Really excited for that one. See you then! You have been listening to Light O'Clock. This podcast is produced by me, Caro Guidolin, a PhD student of the Translational Sensory and Circadian Neuroscience Unit. Music, mix, and sound design are by Ingo Bednarek. We are supported by the Max Planck Institute for Biological Cybernetics and the Technical University of Munich.